Let's think about the proof of the law of conservation of momentum. The law of conservation of momentum is probably learned in high school just as a concept, but it can also be derived by transforming the equation of motion. Let's consider the problem of two objects colliding. Let the mass of one object be m and the mass of the other object be m prime. They approach each other with velocity v and v prime, and both objects collide. When there is a collision, the law of action and reaction works, so the same force works in the opposite direction. Let this force be F. After the collision, the two objects move apart. We will consider this speed as v tilde and v tilde prime. The equation of motion for the two objects in this collision is written as m equals F, where a can be rewritten as the time derivative of velocity. If we define the position coordinate with the right direction as positive, we can express the equation as the product of m and the time derivative of v, equal to minus F for this object. For the m prime object, the product of m prime and time derivative of v prime is equal to F. Then, integrate the both sides of the equations, 1, and 2, with time t, and add two equations together. We can eliminate the denominator dt and the numerator dt, and the integration variable is changed from t to v. The right side is 0 when f and minus f are added, so it is also 0 after integration. Because m is independent of v, integrating m with v gives the first order of v, which is the product of m and v. If the integral region of v is taken as from the pre-collision v to the post-collision v tilde, the result of integration can be expressed as mv tilde, minus mv, plus, m prime v tilde prime, minus m prime v prime. Moving the tilde term to the right shows that the mv plus m prime v prime is the same before and after the collision. The product of mass and velocity vector is defined as momentum, and the above equation is called the momentum conservation law. The momentum is generally expressed as a vector in multidimensional cases. Remember that momentum often appears in quantum chemistry, including the Compton effect and the Schrödinger equation.